You ever wonder how your city decides where to build a new park? Or how scientists can track deforestation in the Amazon, like right now? Well, the answer to both is a technology you've probably heard of but maybe don't fully get: GIS, or Geographic Information Systems. And as we're about to see, it is so much more than just making maps. Okay, let's be real. When you hear GIS, you probably picture somebody hunched over a computer making a super complicated, fancy map. And look, you're not totally wrong, but you're not exactly right either. That whole idea, it's just the tip of the iceberg, and it is the very first myth we absolutely have to bust. All right, so let's get into this. That beautiful map you see at the end, that's just the book cover. The real story, the stuff happening behind the scenes, is the analysis. It's not about just drawing a river on a map. It's about modeling how that river might flood, figuring out which homes are in danger, and then deciding the best place to build a barrier. That is the real power of GIS. And that brings us to myth number 2, the idea that GIS is some kind of magic solve button. You can't just dump a problem into the computer and expect a perfect answer to pop out. It's an incredibly powerful tool for sure, but it's the analyst, the person, who has to ask the right questions and set up the right analysis to get a result that actually means something. Without a smart human guiding it, it's really just a bunch of code. So before we can really build up what GIS is, we've got to finish tearing down what it isn't. Let's get these common misunderstandings out of the way for good. Okay, with those myths officially busted, here's the real deal. A GIS is a system for working with geospatial data. But just look at the words here. It's a journey. First, you capture data, maybe from a satellite or a drone. Then you store it, get it all organized. And then, this is where the magic happens. You analyze it to find patterns nobody saw before. And only at the very, very end do you display it, which, yeah, is often a map. It's a full-cycle problem-solving machine for any question that starts with where. But here's the thing. That system isn't just one piece of software you download. To really get it, you have to think of GIS as a complete toolbox, like a whole ecosystem. So let's open it up and see what's inside. And here's what that ecosystem looks like. It's got 4 crucial parts. You've got the hardware and the software, sure. But all of that is totally useless without skilled people asking the right questions. And those people, they can't do their best work without organizations backing their projects. You take away any one of these 4 pieces, and the whole thing just grinds to a halt. Now, what's really cool here is how this breaks down what GIS actually does. Everything, and I mean everything, starts with geospatial data. That's the raw ingredient. From there, the system is all about getting it, managing it, and showing it. But the really powerful steps, the game changers, are exploring that data for hidden clues and then running deep analysis to find the answers you're looking for. Okay, so theory is great and all, but what does this actually look like out in the real world? This is where GIS stops being just an idea and becomes a tool that literally shapes our lives. Let's see it in action. Let's start with the cities we all live in. Urban planners use GIS to make way smarter decisions. For example, they can layer data showing where people live, where the existing parks are, and what the walking distances are. By combining all that, they can pinpoint the absolute best spot for a new park that will serve the most people. Now let's zoom out to a global scale. GIS is absolutely critical for environmental science. Scientists can layer decades of satellite images on top of each other to create these incredible time-lapse analyses. It shows with total clarity exactly how fast deforestation is happening. It makes the invisible changes to our planet suddenly shockingly visible. In a crisis, GIS can literally be a lifesaver. By mapping out things like elevation, historical flood data, and where people live, emergency managers can identify which neighborhoods are at the highest risk. And even more importantly, they can plan the safest, fastest evacuation routes long before a disaster ever strikes. I mean, we all saw this firsthand not too long ago, right? Public health officials use GIS to map disease outbreaks almost in real time. This spatial view helps them see how a virus is spreading, identify hotspots, and then decide where to send crucial resources like mobile clinics or vaccines. It even changes the food we eat. In what's called precision agriculture, farmers use GIS to create these amazingly detailed digital maps of their fields. They can analyze soil quality down to a single square meter. This lets them apply just the right amount of water or fertilizer exactly where it's needed, which boosts their crops while saving a ton of resources. So we've seen all these amazing final results, but how do you actually get there? Well, the journey from a mountain of raw data to a smart, confident decision is a pretty structured process. And yeah, it comes with its own set of hurdles. And this is basically what that process looks like. First, you collect your data. Then comes the really critical step, integration. This is where you stack different layers of information on top of each other. Think of it like putting a map of roads over a map of rivers, over a map of property lines. That's what lets you do the real analysis, to ask those spatial questions. And finally, you visualize the answer, turning all that complex data into a clear map or chart that anyone can understand. But let's have a little reality check. It's not always a perfectly smooth ride. You've got to be realistic about the challenges. First off, the quality of your data is everything. There's an old saying, garbage in, garbage out, and it's 100% true here. Also, commercial software and data can get pricey. The tools themselves have a pretty steep learning curve, and you need some serious computing muscle for the big project. So, knowing all that, how do you make sure your project works? Well, it really boils down to this. First, invest in the people, not just the software. Second, you have to obsess over data quality. Third, know exactly what question you're trying to answer before you even start. And finally, you should totally explore the amazing open source tools out there that are making GIS more accessible than ever before.
GIS has already changed our world in so many ways, but this field never, ever stands still. So, for our last section, let's take a little peek over the horizon at the future of where. You know, the future is really all about connection. Imagine GIS hooking up with AI to not just map crime, but actually predict where it's likely to happen next. Or picture it integrated with thousands of real-time sensors, the Internet of Things, to manage a city's traffic flow second by second. All of that, combined with more collaboration and a really important focus on using data ethically, is where this is all heading.
If you remember just one thing from all of this, let it be this right here. A GIS is a tool. A powerful one, yes, but it's not the solution itself. Its true value, its real power, comes from the person using it, from their expertise, their curiosity, and the clear purpose they bring to the table. And that kind of leaves us with one last question, a question for you to think about. Everything happens somewhere, so think about your job, your community, your passion. What's the one where question that if you could just find the answer, might actually change everything?